Okay, so yun. So for midterm coverage, the topic will be deflection. So there are different methods in solving your deflection. So actually divided into two categories. We have the geometric method and the work energy principle. So under the geometric method, we have three methods: the double integration, area moment, and conjugate beam. So for this lecture, I will be discussing double integration method. Again, this method, ang i-compute natin is yung deflection and slope ng structure. So first, why do we compute for the deflection and slope? That is because that deflection will be used kapag nagde-design na tayo ng structure. Since we don't want our structure to settle o magkaroon ng deformation, kailangan nating malaman yung possible deformation ng building para makapag-design tayo ng structure na kayang i-withstand yung deflection or deformation. Okay, so the double integration method, again, yung derivation nito nandun na sa BB, pakicheck na lang. So I will go directly to the general equation. So for the double integration method, we have this equation wherein your slope or theta is equal to the square root of the integral of moment over EI dx, wherein yung EI is what we call your flexural rigidity, which is usually constant along the length of the beam. So most of the time, constant siya. If ever na hindi yan constant, no, mag-change lang yung E tsaka yung I. So pag constant yan, you can just factor out yung EI. Okay, so yun na. Just remember yung slope is equal to the single integral of the moment over EI. Double integral naman yung deflection or yung Y. So there are different symbols na pwedeng gamitin sa deflection. Pwedeng delta, pwedeng Y, pwedeng small delta. So basta ang hinahanap dito at Y yung gagamitin natin for the double integration method. Slope is the angle of the deflection. Y is the distance ng deflection. So, ulitin ko na, ang deflection is yung kasi yung structure natin, lagyan mo ng load. Siyempre, nagkikarry siya ng load. There is a tendency to deflect. Now, yun yung kinocompute natin, yung distance from the original position to the deflected shape. So, yun yung hinahanap natin. Okay, so, ito lang naman, dalawa yung general equation. So, let's have this example. Okay, so, para mas maintindihan nyo, I will solve this manually. Yun. So, solve ko manually. Kakopy ko lang yung problem, no? Again, if you have question, please feel free to raise your hand or unmute nyo na lang yung microphones nyo. Copy ko lang yung problem. So, this is length. So, by the way, meron ba sa inyong medyo malakas yung internet that would like to record this discussion? So, maliban sa akin, magre-record din siya para in case of emergency. Meron ba? Mag-volunteer? I will change your setting para ma-record mo. Meron ba? Wala. Okay, so... Wala. So, lahat kayo nakabase lang sa recording ko? Okay, sino? Okay. Prado, wait lang, no? Change ko yung settings. Allow to record. Yan. Okay, so, pakitry na lang i-record din para dalawa yung record na backup. Okay, so yan, balik tayo na. Copy ko lang yung problem. So, I will close this. EI is constant, so I am going to share yung yun. Okay, so ano ba yung tanong nga? We will get the slope and deflection at the midspan of this beam. Okay, so para mas madali yung solution, we will, hindi na lang constant, lagyan natin ng value. So, for example, yung value ng W natin is 10 kilonewton meter. Tapos, yung value ng L natin is 6 meters. Yan. Tapos, di ba, first step is compute for your reactions. So, computing your reaction, use your calculator, di ba? Since this is symmetrical, just 10 times 6 divided by 2 is your reaction. So, this is 30. Tapos 30. Now, before I start solving, I'm going to write the equation. No? We have the slope is equal to the integral of the moment over EI dx, while the double integral of your M over EI is equal to your deflection. Now, ang kulang lang natin is your moment. Ito yung tinatanong. Now, this moment is your moment equation. If you recall in your theory 1, di ba nung magdo-drawing kayo ng shear and moment diagram, kumukuha kayo ng moment equation. So basically, yun yung M. We are going to cut the segment and then we will make, or we are going to get the algebraic moment equation at that point. Now, ang pinakaunang step is you need to check first if how many segments nahahati yung beam. Now, since this is a uniformly distributed load, there's no concentrated load present, no? So walang maghahati sa beam sa dalawang segment. So this is just one segment, segment A, B. Wala kang concentrated load, so hindi nahati yung beam. So meron lang tayong one segment. Now, pag may one segment, ikakat lang natin siya anywhere along the beam. So cut natin siya. So cut tayo, no? Tapos set natin na X. And then, kukunin natin yung moment equation dito. Di ba pag nag-cut tayo, we have here our internal shear and internal moment. Now, what we want is the internal moment. So, since this is the first discussion, idodrawing ko muna yung FBD. Later on, hindi ko na idodrawing yung FBD, direkta na natin kukunin yung moment equation. So, cutting or drawing the free body diagram. As you have here 30. Tapos, this is 10. 10, di ba? 10. And yung distance mo is X. Yan. And then again, you have here internal shear. Tapos internal moment. Now, yung moment na to, ito yung hinahanap natin. Now, how do we get that? Di ba? All you need to do is do summation of moment at this point. So, para mapakita natin kung paano, lagay ko muna yung equation. So, summation of moment at 0 point is equal to 0. Assuming positive clockwise, isa-isahin ko lang, no? So, we have 30 times x, force times distance, 30 times x. Clockwise yung papunta siya sa point na to, di ba? Clockwise, so positive. Then we have your uniform load. This is counterclockwise, papunta sa, yung arrow, no, dun sa nako-confuse sa sign convention. Yung arrow ng load, papunta kung saan ka nag-moment, so papunta dun sa dito. So this is creating a counterclockwise rotation. So minus 10, gawin mong concentrated load, so 10x, times the moment arm, x over 2. Di ba? Pakita ko lang kung ano nangyari. 10, magiging siyang concentrated load, di ba? Gawin mong 10x. Ito na siya, 10x times the moment arm, x over 2. Kasi kalahati ng x. So, yun. And then you have your moment, which is counterclockwise, so negative m. And then, writing the equation now, we have m is equal to 30x minus 5x squared. Now, for the shorter solution, so para wag nyo na tong isulat sa mission of moment, pwede man dito nyo na lang tingnan. Kapag hinahanap yung moment, lahat ng force na opposite sa kanya is positive, and then yung same direction sa kanya is negative. So, isa-isahin natin. No? You have your moment that is counter. So, moment, counter siya, equal to 30x, opposite, so positive, so 30x. 10x, so same direction, so negative. 10 times x over 2, which is equal to this one. So basically, galing lang naman to dito sa equation of equilibrium natin na moment. Para lang wag na masyadong mahaba, doon na kayo mismo tumingin sa free body diagram. Yung moment, kapag same yung direction, opposite direction is positive, kapag same direction is negative. Basically, galing lang naman yan dito kasi nag-transpose tayo. Pero ito yung, para lang mas shorter yung solution. Okay, so, since you already have your moment, this moment here will be used dito sa equation. Now, solve na natin. Since meron naman na tayo ng moment. So, solving now, we have, ang tinatanong is slope and deflection, di ba? So, slope, ito na lang, y, sorry, is equal to the double integral of m over ei dx squared. So, first integral muna. Copy ko, we have 30x minus 5x squared, parenthesis dx squared. So, double integral, no? So, integrate natin nung first muna. Integrating it first, we have 30x, di ba? Sa integral nyo, power rule, kapag x, yung constant, magpa-plus 1 tayo sa exponent. So, 30 x, 1 plus 1, kasi yung x, di ba, may exponent yan na 1. So, 1 plus 1 is equal to 2. And then, adding that sa denominator natin, which is 2. So, ganun yung equation. Next, minus 5x squared. So, 2 plus 1 is 3. So, minus 5x cubed all over 3. Then, please remember, no, kapag ganitong wala tayong limit, we have your integrating constant na C1. And then, dx. So, kung mapapansin nyo, this is the first integral na agad. So, this is actually equal to your theta. Pero, kapag in-integrate pa natin siya ng isa pa, that will now be your deflection. So, integrating it again, we have 30x 2 plus 1, so magiging 3. So, magiging 30. I-simplify na tuloy natin. So, this will be equal to 15. Good. So, we have 15. X, 2 plus 1 is 3. 3. Then, minus 5. X3 plus 1 is 4. And then, since you have a denominator, i-add nyo dyan yung, mamultiply nyo dyan yung 4. No? And then, you have C1x. And then, another integrating constant na C2. So, you have your general equation. Ulitin ko, this equation is for your slope. And this equation is for your deflection. Now, if you will notice, hindi pa complete yung equation natin since we still have your integrating constants. Now, how do we eliminate this? To eliminate this, you need to go back to the problem. And then, i-check nyo kung saan tayo pwedeng mag-substitute ng variables. Now, ang pwede lang nating masabi is at what point on the beam na 0 yung value ng y. Kapag 0 mo kasi yung y, pwede tayong makakuha, ma-eliminate natin yung y, tapos pwede nating makuha yung value ng C2 tsaka C1. So, yung first is, di ba, kung i-drawing mo yung deflected shape nito, so, for example, nag-deflect yung beam, di ba? Ang itsura niya pag magdi-deflect siya, ito yung original beam, siyempre ganito yung lalabas. Ito yung deflected shape. Now, what we know is at x is equal to 0 or at the origin, since may support siya, wala siyang deflection or wala siyang deflection. So, yung y mo dito is 0. Isa pa, dun sa reaction mo sa B, of course, yung y mo din dyan is 0. Tama? Dito sa magkaiba lang dulo, since we have support, the value of your y is equal to 0. So we will use that. We call that your boundary conditions na tinatawag. So we may use that for us to solve. Pwede natin itong gamitin para ma-solve yung integrating constant natin. So, gagamitin natin siya, no? So at x is equal to 0, y is equal to 0. Kasi nga, at this point, 0. Tapos yung isa pang condition, yung isa pang condition is, at x is equal to, yung sa dulo is 6 meters, ang y mo is equal to 0 din. So, substituting that here, kung hindi ko na isusulat, mahaba kasi. Kunyari, substitute mo yung y na 0, tapos substitute mo yung x na 0, cancel, 0, cancel, 0, cancel. Y, 0, cancel. Ang matitira is C2. Therefore, your C2 is equal to 0. Diba? Kung mag-cancel 0, 0, 0, 0, so C2 mo is 0. Now, if x is equal to 6 meters, ano yung magiging value ng C1? So, ang gagawin mo is substitute mo yung 6 dito sa equation na to. So, ito na mismo yung gagamitin ko, no? So, this is 0. And this is 6. Palitan nyo to ng 6. 6. Palitan mo ng 6. This is 0 based dito sa unang equation. So, you can get the value of your C1. Diba? Since siya na lang yung unknown. So, by using your calculator, you can get the value of your C1. Pakitry ngang isolve para ma-check ko kung tama yung mako-compute. 15 times 6 cube. Hmm, 6. $90 ba? Tama ba? Negative 90? Please check kung tama.
Yes, ma'am.
Okay, sige. Negative 90. So, we now have the complete equation sa pag-solve. So, i-rewrite na natin siya, yung pinaka-general equation. So, ang slope mo is equal to 15x squared minus 5x cubed over 3. Ang C1 natin is negative 90, so minus 90. While your y is equal to 15 over 3, so 5x cubed minus 5 over 12. 5 over 12 x raised to the 4th. Then minus 90x. Tama? Minus 90x. Tama na ba yung substitution ko? Yan. So, and then, ang tanong is, what is the slope and deflection at center? Tama? Nasa center, ang value ng x natin is, if the entire length is 6, so ang value nung hinahanap natin, or yung x is equal to 3 meters, half, kasi nga midspan. So, hanapin natin yung slope tsaka deflection at the center. So, at x is equal to 3 meters, substitute mo lang yung 3 dito sa equation natin to get your slope and deflection. So yun, your theta is equal to, sa paki-substitute, pati yung y, substitute nyo lang yung value nung x, which is 3 meters. Solve natin, 15 times 3 squared. Then, paki-double check, no? Kasi minsan namamali din yung sulat ko or input. Minus 90. So, of course, yung slope nyo is equal to 0. So, tama. 0. Correct. Ang y natin is 5 times alpha x. Sorry. We have 3 cubed. 5 times negative 168.75. Tama ba? This is kilonewton. Yung unit pala is kilonewton cubic meter all over the flexure rigidity, which is your EI. Okay, check nga. Tama ba? Or mali yung calculator ko? 5 times 3 cube minus 12.
Tama.
Tama?
Tama po.
Tama? Okay, sige. So, this will be your final answer. Yung slope, bakit siya 0? Kasi, sige, explain ko lang na bakit siya 0, as nasabi kong tama. Kasi kapag symmetrical yung beam, obviously, yung highest point ng deflection is nasa gitna. Tama? Kasi nga symmetrical siya. So, kapag nag-deflect siya, ang maximum deflection niya is nasa gitna. Now, imagine this as a slope. Kasi nga ang hinahanap natin dito is theta, di ba? Ito kanyari, theta. So, since slope yan, meron niyang rise over run angle, di ba? So, habang lumala, ito yung line na straight line, habang pa-inclined, di ba? Ganon. Now, habang papalapit yan sa highest point, nagiging siyang straight or horizontal line. So, therefore, at the point of maximum deflection, wherein flat na yung slope, ang theta natin or ang slope natin is equal to 0. Now again, dun lang yan sa point of maximum deflection. So, tama yung equation natin since ang nakuha nating slope sa gitna is equal to 0. Now, if ang tanong, for example, what is the slope at A? Kunyari, ano daw yung slope dito? Ang gagawin nyo lang, simple lang is, using this same equation, gawin nyo lang is at x is equal to, gawin nyo lang na at x is equal to 0. Kasi nga at point A, tapos substitute nyo lang siya ulit dito sa general equation to get the slope. Now, to get the deflection at, say, 2 meters from the left support, for example, the at x is equal to 2. So on and so forth. So, ang double integration method, ang ginagawa natin is we are getting the general equation for the entire beam. Now, in this particular example, ito yung general equation natin. Now, once you have this, ang advantage ng method na to is you can now get the slope and deflection at about any point on the beam. All you need to do is substitute the value of x. Now, please remember sa double integration method, isa lang yung reference point natin. Ang reference point natin is at the left end. So, 0 to, at this point is x. So, kung gusto nyo mag-reference sa right side, for example, right side yung gagamitin yung FBD, the distance will be 6 minus x, not x. No? So, dapat dito ka lang, papunta ka lang sa left to right, x. So, yun. Fixed yun. So, any question? May question ba? Wala naman? Okay, so kung wala, no, this is an example of the double integration method. So, tingnan natin, balik tayo dun sa dito. Balik tayo sa PowerPoint. Check natin yung sagot ko kung tama. Kasi dito, ang nakalagay dito is var ano lang, di ba? So, yun. Ang final answer dito, yan, ang deflection daw is 5WL raised to the 4th over 384 EI. Remember, ang W yung ginamit ko is 10. So, 5 times 10 times, ang ginamit kong L is 6. Tama? So, 5 times 10 times 6 raised to the 4th over 384. Dapat, ang sagot is 168.75. So, check natin. Ang lalabas is correct, 168.75. So, yan, tama. Okay, so, use this lecture note for review, no? So, yun. Ang tanong pala is slope at A. Ito na yun. Substitute nyo lang yung X as 0 to get your slope at A. So, yun. Next problem. Okay, so, again, I'm going to solve this manually para mas maintindihan nyo. I'm just going to copy the problem first. So here we have a cantilever beam. Cantilever beam siya, no? Tapos may concentrated load sa free end. We have here 15. Tapos distance is 20. Tapos E is equal to 29,000 kips per square inch. And then I, or your modulus of elasticity, is equal to 758 inch raised to the 4th. Okay, yun. So, let's solve. Okay, so, ulitin na. Ang gagawin natin is we will get the general equation. Now, in this problem, again, unang-una, i-check nyo kung ilang segment ba. Now, here, since yung concentrated load mo is nasa free end naman, isang segment lang ulit siya. So, this is your A, this is your B. Now, kakat natin siya into X. Diba? This is your, cut natin siya. This is your X. Yung kabila, this is, kung X to, this is 20 minus X. Now, remember, kapag cantilever beam yung problem, I suggest na gamitin nyo yung side kung saan nandun yung load instead of using the side kung saan nandun yung support. Now, the reason is, if you're going to use the right side, you don't need to compute the reaction. Kung tinatamad kayo, gusto nyo mas mabilis yung pag-solve, doon na kayo sa free end. Kasi diba, hindi mo na to gagamitin, right side lang, so you don't need to bother to solve for the reactions here. So in this example, kunyari gamitin natin yung right side. So instead of drawing this, sige, drawing ko tuloy yung FBD. Pwede din naman na wag nyo nang i-drawing, no? Lagyan nyo na lang dito ng M. Diba, ito lang naman yung itsura niya, basta ito lang yung titingnan nyo. And then tulad nung sabi ko, to write the moment equation, moment is equal to kapag same yung direction negative. So moment is about this point, clockwise. Yung 15 papunta sa point na yun is clockwise also. So M is equal to negative 15. Ang moment arm ng 15 is 20 minus X. Now, since you only have one load here, ito na yung moment equation natin, maikli lang. So next step is do your double integration for the deflection. So again, sorry, ano yung tinatanong? You are asked for the slope and deflection at point B. Okay, so slope and deflection at point B. Teka natin, ayusin natin. Yan. Now, you have slope is equal to the integral of this negative 15. Since constant yung 15, no? Erase ko to. Since constant yung 15, pwede nyo na siyang i-factor out, ilabas nyo sa integral sign. So you have negative 15, para madali. Integral of 20 minus x dx. Tapos, solving it now or integrating it, you will have negative 15 tapos times 20 minus x squared over 2 dx. Diba? So this is your slope equation. Sorry, plus dx plus c1. No, plus c1. And then integrating it again, we'll get your deflection. So integrate natin siya ulit. So the integral of, ilabas nyo ulit yung 15. Yung 2, pwede nyo din siyang ilabas. So 15 divided by 2 is 7.5. So negative 7.5. Factor out nyo yung mga constant, no? 7.5 integral of 20 minus x squared plus c1. This should dx. Tapos, so your y is equal to negative 7.5 times 20 minus x cubed over 3 plus c1x plus c2. So, ito na yung equation natin. Mabilis lang. Sorry, no, nakalito pala. Yung 15 dito lang siya para lang siya dito. Hindi siya kasali sa C1. So, yun. And then, same lang yung method ng pagkuha ng C1 tsaka C2. You need to consider the boundary conditions. Boundary conditions, balik ulit tayo dito sa figure. And then, solve natin yung, tingnan natin yung deflected shape. So, since you have here a fixed support, kapag mag-bend yung beam, ganito yung itsura niya. Straight line sa simula kasi walang deflection sa fixed support. Bakit? Because, di ba, ang fixed meron niyang moment reaction. Therefore, it resists rotation. So, wala kang deflection. So, kapag fixed support, walang deflection. So, straight line muna siya. Then, at some point in the beam, tsaka siya magde-deflect. So, gaganitong lalabas niyan. Now, based on this beam, the only support na 0 yung deflection is at A. So, we can say here your y is equal to 0. So, kailangan pa natin ng isang equation. So, based on this figure, what else can we get? Tulad nung sabi ko earlier, at this point, no deflection and no rotation. Therefore, at point A, your slope is also equal to 0. So, meron na tayong dalawang equation. Sulat ko yung boundary condition na nakuha natin based dito sa figure. So, ito yung boundary condition. At x is equal to 0, your slope, your y is equal to 0. And then at x is equal to 0, your slope is also equal to 0. So, we will use these two equations to get your C1 and C2. Now, tingnan ulit natin. Hindi ko nasusulat yung equation. Sa C1, sa C2, x0, y0. So, cancel to, no? Cancel yung x, then cancel to. So, C2 is 0. Now, at x is equal to 0, y is equal to 0. So, we will use this equation instead. Kasi andito yung slope. Hindi yung y. Ang gagamitin natin is, since this is slope, ito yung gagamitin natin. So, substitute nyo na. So, dito ko na susulat na. So, magiging tong 0. Tapos, yung x, gagawin yung 0 din. Tapos, C1. So, therefore, anong lalabas na sagot? C1 is equal to meron ba? Ilan? Wait, chat. Oh, sorry, kakabasa ko lang. Alin yung tinatawag na always 0? Sorry, Rosaro. Alin yung tinutukoy mo na always 0? Hello? Sorry, hindi ko naintindihan yung tanong kung alin yung tinutukoy mo na always 0. Kung yung fixed support, pag fixed support, laging 0 yung deflection, of course, kasi no vertical movement sa fixed. And then always, kapag fixed support, 0 yung slope. Kasi nga, tulad ng sabi ko, ang fixed support natin is meron yung moment reaction. So, it resists rotation. Since slope is rotation, so wala kang deflection dyan. Straight line yan dyan. Okay, C2 0, C1 is equal to 0. Tapos, so magiging general equation natin is ito na. Substitution na lang ulit. Rewrite na lang natin. Wait lang. Ayun, sige. Okay, fixed support. Now, pag may question na chat na lang siguro or raise your hand para mapansin ko agad. Okay, so for your theta, we have negative 15. Sorry, I forgot the EI. Pakilagay na lang dyan sa solution. 15 over EI times 20. Sorry. Nalito ako, no? Cross out to na. Ang ginawa kong solution is yung dun sa isa, dun sa shortcut, which is hindi ko pa tinuturo. Hindi pwedeng ganito yung pag pag-integrate nito. Ay na, sorry, malito. Ito. Ito kasi the solution is dun sa shortcut. Nalito ako na. Hindi pala ito shortcut. Balik ka dito, Ayun. Balik ko dito. Ulitin ko na lang. So, we have theta is equal to negative 15 integral of 20 minus x dx. Dapat ganito. And then, integrating it, we have negative 15. Lagay ko ng EI. Kakalimutan ko. Over EI. And then, 20x minus x squared over 2 plus C1. Yan. So, dapat yung pag-integrate mo dito is per constant, no? So, yung isa kasing integration, yung ginawa ko, kung mapapansin nyo, as a whole ko siya in-integrate, ito. Now, this will be done mamaya, later on siya mangyayari. Nawala ba? Wait lang. Nag-disconnect. Yan. Ulitin ko na, ganito siya kapag ganito yung ginagawa natin. Ito yung 20 minus x. You need to integrate it individually. Now, since this is 20, so nag-rin siyang 20x, then x squared over 2 plus C1, the integrating constant. Then for y, integrate it again once. So negative 15 over EI. integral of, copy ko na muna 20x minus x squared over 2 plus c1 dx. Tapos, integrate natin, no? Negative 15 over ei. So, 20x squared over 2 is equal to, dire-diretsuhin ko na, no? 20x squared over 2, so 10x squared. Minus x cubed. 2, tapos, di ba 3 over 2, so 2 times 3 is equal to 6. Plus c1x plus c2. Yun. Kaya pala. Then, same lang na yung dito, yung boundary condition. So, dito ko nilagay sa right side. At x is equal to 0, y is equal to 0. Ang makukuha nyong c2 is equal to 0. Now, at x is equal to 0 ulit. Theta is equal to 0. Ayun. Ang lalabas dyan na value ng C1 mo is also equal to 0. Good. Then after this, solve na natin. Ito na yung general equation. So cancel ko na, no? Since 0 yung C1 tsaka C2, eliminate lang natin to. This is 0, 0. For the final equation for your slope, 0 din to. Yan lang. Tapos, ito na yung dalawang equation. Final equation is ito for the slope and ito for the deflection. Now, at x is equal to, ang tinatanong is dun sa free end. Ito sa free end. Ang x natin is equal to 20. So, at x is equal to 20, slope is equal to, compute na lang, at x is equal to 20, y is equal to, so yun, substitute nyo na lang dito yung x to get your y, then substitute nyo dito yung x to get your slope. Pakitry, paki-calculator, kung anong lalabas. Ano yung sagot? Okay, try natin. Slope. Lobot na ang calculator ko. Kayo na lang. Anong lalabas na sagot? Ay, ito. Gumana pa. 20 times 20 minus 0.5 times 20 squared. Negative 3,000. Tama ba? Yan, negative 3,000.
Tama po, ma'am.
Okay, tapos yung y naman, tapos ba't ko ito nilagay na y? Y is equal to, paki-substitute, negative 15 times 10, 20 squared, minus 20 cube. Negative 40,000. Tama?
Negative 40.
Ayan. So, yung unit nito is
Ang
kips
AI, ma'am, ano, ma'am?
over EI yan, over EI. Tapos, ko-convert natin to since given yung EI. Ang unit nito is kips per square. Naka-fit ba tayo? Naka-fit tayo. Feet. Squared, ito. Kips, tapos cubic. Always remember, kapag radian, squared. Kapag deflection, cube. Now, since ang gamit natin dito is kips, tapos ito, naka-fit ito, di ba? So, substitute natin yung given. We have 29,000 KSI, kips per square inch, then inch raised to the fourth. So, since ang unit natin dito is kips tsaka feet, convert lang natin yung feet sa inches. So, converting, we have theta is equal to negative 3,000 kips Then we have 12 inches over 1. Then squared, para makancel yung feet, maging inches siya. Then sa denominator, we have E, 29,000. Tips per square inch. Tapos we have 758 inch raised to the 4th. So kung mapapansin nyo, no, we have inch squared, inch raised to the 4th. So cancel tong squared, natitira squared. Then yung sa taas naman, feet, kinonvert natin, magiging siyang inches. So makakancel din yung inch. Makakancel pa tong natitirang 2 sa baba. Tapos tong kips, cancel, kips, cancel. So if you will notice, the final answer will be in inch, radian kasi ma-eliminate lahat ng units. So your theta is equal to, kung ika-calculator, we have negative 3,000 times 12 squared, di ba? 12 squared. Tapos over EI, 29,000 times 758. So the unit is negative 0.0197 radian. So ito yung naka-radian siya kasi unitless, na-cancel lahat ng units. Now for your Y, convert natin, we have negative 40,000. So, hindi ko na ito susulat, no? Ang pagkakaiba lang, since this is squared, ito cube, so magiging times 12 cube to. Tama? In inches na yan. All over, copy nyo lang yung EI. 29,000 ulit. Sorry, ito yan ha. 29,000 times 758. Now, since cube to, yung sa baba magiging squared na lang, no? May matitira tayong inch. So, ang unit ng deflection natin is naka-inch siya. So, negative 40,000 times 12 cube over 29,000 times 758. Negative 3.144. I-check nga. I-check. Yan. So, check ko nung yung sa presentation, ha. Let's see. Yan. So, tama yung sagot. We have here Y, 3.144 inches, and then the slope is 0.0197 radian. So, question so far? Wala naman. Yan. Now, kung mapapansin nyo, yung first two examples natin, they are both a single segment lang. Diba? So, isang cut lang yung ginawa natin kasi single segment lang siya. Parehas yung example. Now, for this next example, ayun. For this next example, nahati siya sa tatlong segment. Now, how do we know kapag nahahati sa segment? Titingnan nyo lang yung beam. Saan ba dito yung draw? Yeah. Titingnan nyo lang yung beam. Tapos, kapag may concentrated load kasi, ibig sabihin, nahati niya yung beam. So, ito yung unang segment. Nahati niya dahil may concentrated load. Ito yung pangalawang segment. Then, ito yung pangatlong segment. Now, anong ibig sabihin yan? Now, if you recall, sa theory 1 nyo, pag kumukuha kayo ng moment equation, depende siya sa number of segments. So, kasi kapag mag-cut ka dito, kailangan mong i-cut na 3 beses. Then, kukunin mo yung moment equation per segment. Kasi iba-iba yung moment equation dahil nahati sila ng concentrated load. So, in that case, yung method of double integration, yung double integration method, usually, ang ginagawa is, you need to cut it 3 times, x x, then kukuha ka ng tatlong moment equation, tsaka mo siya integrate. Now, masyado siyang mahaba, di ba? So, we have here a shortcut na instead of dividing it into 3 segments and then getting 3 different moment equation, we may just cut it at the 3rd segment, provided that ang gagawin nating pag-integrate is tulad nung pag-integrate na ginawa ko kanina, yung namali ako, yung hindi mo siya i-integrate per constant. So, kung nasa loob siya ng parenthesis, as a whole mo siya i-integrate. So, yun lang yung rule. So, erase ko na to. Yun. So, instead of getting a moment equation per segment, all we need to do is cut it at this end and then get the moment equation. So, medyo mas mahaba lang. Sige, solve ko ulit sa paper and then copy ko lang yung problem para mas maintindihan nyo kung paano yung have here. I hope also na kasi yung pagkuha ng reaction, marunong na kayo, di ba? So, hindi ko na siya isa-isahin. Then, please be careful kasi kapag namali kayo sa reaction, mali na kayo sa pag-solve. So, as much as possible, always double-check yung reaction nyo kasi hindi naman nawawala yung mamamali kayo ng input. Okay, so yan. Tanong, what is the mid-span deflection? So, x is equal to, this is 4, 4, 2, so 8. Ulan. Yan. Okay, so wait lang. Lumalabas yung yan. Ay, sorry, yung distance hindi ko na-copy. You have 244 meters. 4 meters, tapos 4 meters. Ang gagawin natin, instead of cutting it per segment, ikakat lang natin siya once. So, ganito yung cut nyo. Ang cut nyo is dun sa 3rd segment. Tapos, andun dito yung x. So, ang kukunin yung moment equation is andito. Now, hindi pwedeng right side yung kukunin nyo, no? Dapat dito kayo kumuha. Kunin nyo yung value, yung moment equation. At this part of the segment. Now, yung nalilito, no? Since this is x, kung kukunin mo yung distance ng dalawa, this is, kung x to, ano to? Anong distance nito? X minus 6. So, ito x minus 6. Ito naman, kung yung distance nito, this is x minus 2.